So let's see. So we have composition of functions part 2. So here, the other day, we did, just like on the whiteboard, f of g of 2, or f of g of a number. Today, things are going to look a little bit different. We still have two functions, f and g, but if you look here, we have f of g of x. So this time, we don't have a number. We're actually going to be composing two entire functions. So that means our answer is going to have the letter x in it. So same process as Friday. I want you to start with the function that's on the right. So that's that g of x. That's going into the function of x. So we work right to left here. You're going to take the entire function, 2x minus 1, and where do you think you're going to put it? Into f. You're going to put it into f where the x is. Okay, so you're going to have 4. Now instead of x, put some parentheses, and you're going to stick that entire function of g into those parentheses. You all set? Yep. Cool, thank you. Good experience. All right, so now you just have to simplify that. I would distribute the 4, and what do you get as your final answer? 8x minus 4. That is your new equation. That is what f of g of x is. It's a new function that you could then use to evaluate something. Okay? So that's what we're going to do. We're going to have an entirely new equation, an entire new function. Well, now we can go the other way. We can find g of f of x. So this time, what function is going into the other? F is going into g. All right, so I'm going to take this 4x. I'm going to put it into g where the x is. So we'll have 2, but instead of x, I put 4x, my function of f, minus 1. So how does this one simplify? Yes. Question? Yeah. Because I'm only replacing the value of x. The rest of the function stays the same. So g still stays the same. Instead of x, though, I just put some f in. That makes sense? We'll see plenty more. You'll get the hang. All right, but that's the basic one. So the one thing I want you to notice here, just like I mentioned a minute ago, yesterday, Friday, when we composed our functions, the input was a number. So we put a number into the composition, which meant that our output or our answer was also a number. Today, we're composing two functions where the input is in terms of x. That means there's an x in the input, which means our output also will have an x. It'll be in terms of x. Okay, so that's the biggest thing to notice. Today we're not going to get a number as our answer. We will have to have a variable in our final answer. All right, as we go through today, they're going to get a little bit more challenging. So let's start with 3x plus 2 is g of x, and h of x is 2x minus 4. I want to find g of h of x. So which function goes into the other? H goes into g. So I'm going to take this whole function of h and put it into g, just replacing the x value. So you'll have 3. Now instead of x, you're going to stick that 2x minus 4. And then you have to put the plus 2 on the end. That's still part of g of x. Yep, so now we distribute. You get 6x minus 12 plus 2. And then you combine these like terms. So what's your final answer? 6x minus 10. Good. That is your new function, g of h. So we've really stuck with linear functions so far. That means no squares. So bless you. Hasn't been too bad yet. Let's try this one. H of x is negative 3x. G of x is negative 2x minus 1 all over 3. Let's find h of g. So I'm going to take g, and again, put it into the left function. Put it into h. So this entire fraction is going to go in for x in the function of h. So of negative 3, I want you to write a big set of parentheses and put that entire 2x minus 1 over 3. Now, how do I simplify this? What would you do? What do you think? We're multiplying. You don't have to flip anything. That's only for dividing. What would you do to simplify this? Okay, what gets multiplied by 3? All 3 things? I don't think all 3 things. Because think about negative 3 is really negative 3 over 1. So when you multiply fractions, you multiply straight across the numerator and straight across the denominator. So really, I only have to multiply negative 3 times the numerator. So then your numerator would be what? Negative 6x plus 3. What's your new denominator? 1 times 3. It's just 3. All right, well, now we can simplify that, though, right? Because everything here, I can simplify negative 6 over x, or negative 6x over 3, right? That'd be negative 2x. And what about the 3 over 3? Plus 1. That would be your final answer, negative 2x plus 1. So that was one thing you have to remember, those rules about fractions. This is really over 1. You multiply across the numerator and denominator. Not too bad yet, right? Well, let's do some with squares. Let's flip your paper over. Let's see what happens when I add in an x squared. It's not going to be too hard, but there are some rules that we forget. I have f of x and g of x. First, let's do the easy one. Let's take g and put it into f of g of x. So we're going to take this x squared plus 6 and put it into x. So we start with x squared plus 6. That's replacing the x right here, plus 5. Well, how am I going to simplify this one? We're almost done, but they'll combine here. Just the 6 and the 5, right? So this becomes x squared plus 11. All right, that one's pretty easy, right? There was no distributing, there was nothing else. When I look at it the other way, though, the squared makes it ever so slightly more challenging. Because this time I'm putting f into the function of g. So let's see, that means this time I'm taking x plus 5 and putting it in the other function for x. So here's where you have to watch your parentheses. X plus 5, but what do I have to do with that set of parentheses from g? I have to square it, and then add 6. So what would be my next step here? Do what? Not really distribute the square. We've done this a couple times. Remember, don't write this down. This is not equal to x squared plus 25. That is not the right answer. What do you have to do? You have to write it twice. You have to rewrite this as x plus 5 times x plus 5. Now, some of you I know can do that whole step in your head without writing it down. That's cool. I'm going to write it down for you, though, just so other people can see it. Because this is what it means to be squared. Take the entire quantity times itself. So now you FOIL, or you use your distributive property. Okay, so I'm going to let you FOIL for a second. And then when you get there, you can check your answer with what I have up here. I can do that in my head a little faster. If you want to skip steps, you can do that too. You distribute x times x, x times 5, 5 times x. We should get down to here. We okay so far? All right, so I combine my final like terms. What's 25 plus 6? 31. All right, so that'll be x squared plus 10x plus 31 is your final answer. Okay. Good so far? I think we have one more. It's not super hard, right? But it's a little bit harder than Friday. Can you give me that at least? A little bit. I at least kind of tricked some of you on that one. At least some of you wanted to not do the right thing. All right, this one is our last one. I have f of x is 2x minus 1, and g of x is 3x squared plus 5x minus 8. Let's do B. We'll just skip A. Let's just do B. You can start A if you want to. It's okay. You have enough pencil lead to do it. Let's do B together. So B, I'm going to take F and put it into G. So how many X's are in G this time? 2. So I have to take it and put it into both X's that are in G. Both of them. So I have 3. Now instead of X there, I have 2X minus 1. I square it. That's the first term. Plus 5. And instead of x here, 2x minus 1. And then minus 8 on the end. So it's a little bit more involved this time. What would you do next here? I would distribute after. Actually, the first thing you need to do here is rewrite the first 2x minus 1 squared. Okay? And then distributing will be at the end. So you have 3 times 2x minus 1 times 2x minus 1. And then we can distribute over here if you want to, though. I would do plus 10x minus 5 minus 8. Then I would multiply or FOIL, distribute this 2x minus 1, 2x minus 1 right here. So let's do that one real quick. Redistribute and collect like terms. So when I multiply these out, you should get 4x squared minus 4x plus 1. Yeah? All right. Now I would distribute the 3. So we'll distribute the 3 here, and then we'll collect like terms, and we'll be done with this problem. So that gives me 12x squared minus 12x plus 3 plus 10x minus 5 minus 8. All right. Where's the last one? So nothing combines with 12x squared. What about the x's? How do those combine? Negative 2x, and my constants, 3 minus 5 minus 8. Negative, yes, okay, sorry. I think about that one. 5. So you should have 12x squared minus 2x minus 10. So there was a little bit more involved in that process. The hardest part of these is they're not necessarily hard to do if you have the idea that you have to replace the entire function. But the mistakes people make, they don't multiply out the squares correctly, and sometimes they forget to tag on those like minus 8s or plus 1s at the end. Okay? All right, not too bad though, right? All right, so here's what you're going to finish up with today. You are going to